In this study, the impact behavior of and fractography of 6061 alloy with trace addition of SN has been investigated. 6061 alloy are the aluminum magnesium silicon alloy which contain magnesium silicon as the major alloying elements. Magnesium and silicon form the hardening Mg2Si phase. This alloy is heat treatable, cheaper than aluminum copper alloys, have high resistance to corrosions and good strength and are light in weight. Hence, these alloys are widely used in aerospace and defense applications. A vacuum die casting and furnace was used for casting of the investigated alloy. The casting setup is shown in figure 1. The chemical compositions of the alloys are presented in table 1. The cast alloys were homogenized for 4 hours at 30 degrees centigrade and then were hot rolled at 460 degrees centigrade and then were PKs at 190 degrees centigrade. Figure 2 shows the impact fracture specimen used in the studies. The micrograph in figure 3 reveals three phases: phase A white, phase B dark black and phase C as light gray in the alloys. From EDS analysis, the phase C is identified as aluminum, phase A is identified as AlFeMnSi and phase B is identified as Mg2Si phase. Table 2 shows the pK's hardness of the alloys. It was found that in comparison to alloy A, the hardness of the alloy B decreases and alloy C increases. Figure 4 shows the impact strength of the alloys in as-cast, as-roll and pK's roll state. An increasing trend in the toughness of the alloys was observed from as-cast state to pK's roll state. It was observed that pK's aging treatment was more effective in increasing the toughness of the alloy. Moreover, it was found that SN addition has resulted in increase in the impact strength of the 6061 alloys. Figure 5 shows the impact fracture surface of the alloys in as-cast and pK's roll conditions. Fractography of the as-cast alloy reveals crack, fractures, and dimple features, indicating locally brittle and ductile failure. It can be seen that relative to the as-cast alloy, dimples are smaller and denser in PK's roll alloys. The impact surface, fracture surface of the PK's roll alloy were mostly dominated by smaller dimples, indicating that the fraction mechanism is primarily by ductile mode. Moreover, the EDS analysis in figure 6 detects AlFeMnSi elements in the cracked particle. This indicates that AlFeMnSi elements were accountable for fracture of the alloys. Conclusions. The conclusions are summarized as follows. Trace additions of SN improved the impact strength of the 6061 alloy is a new finding which has not been reported earlier. The impact strength increases significantly in pK's roll state. The FED's AlFeMn SI particles are primarily responsible for fracture of the alloys. The fractures in the as-cast alloy took place by mixed ductile and brittle mode by larger ductile dimples, cracks and cleavages, while in the PK's roll alloys was primarily by ductile mode by smaller dimple features. The enhancement in the impact strength of the alloy due to the addition of SN may minimize the structural damage of the alloy due to an impact. Hence, one can consider SN added 6061 alloy suitable for aerospace application where impact safety is a major concern.